In this video, we are going to look at another example of how mass percentage calculations are used. The scenario presented to us this time involves calculating the mass of an element in a given sample of compound. For example, how many grams of the elements magnesium, nitrogen, and oxygen are in a 58.4 gram sample of the ionic compound magnesium nitrate. To solve this problem, we are going to start by calculating the mass percentage of each element in the compound magnesium nitrate. And then we are going to use these percentages to calculate the mass of each element in the 58.4 grams of the magnesium nitrate sample. We need to start by calculating the molar mass of magnesium nitrate, which is going to equal 1 times the molar mass of magnesium. There is one magnesium atom in this formula unit, plus 2 times the molar mass for nitrogen. We can see that the nitrogen has a subscript of 1 inside the brackets, but we can see that there is a 2 outside the brackets. So there are a total of 2 nitrogen atoms in this formula unit. And finally, we are going to add 6 times the molar mass of oxygen. We can see that the subscript for oxygen is 3 inside the brackets, but there is a 2 outside the brackets, meaning we have a total of 6 oxygen atoms in this formula unit. We get the molar mass for each of these elements from the periodic table, and so the molar mass of the entire compound will be 1 times the molar mass for magnesium, 24.30 grams per mole, plus 2 times the molar mass for nitrogen, 14.01 grams per mole, plus 6 times the molar mass for oxygen, which is 16.00 grams per mole when expressed as 4 significant figures. When we plug all these numbers into our calculator, we get the molar mass equal to 148.32 grams per mole for the compound magnesium nitrate. So we can now start calculating the mass percentage for each element. The mass percentage for magnesium will be the contribution from magnesium, 1 times 24.30 grams, divided by the total mass of 1 mole of the entire compound. Plugging those values into our calculator, we get 16.38%. The percent mass for nitrogen will be the contribution from nitrogen, 2 times 14.01 grams, divided by 148.32 grams, which is the mass of 1 mole of the entire compound. We put those values into our calculator and we get 18.89%. Finally, the mass percentage for oxygen will be the contribution from oxygen, 6 times 16.00 grams, divided by the total mass of 1 mole of the entire compound, which is 148.32 grams, with the final calculated value being 64.72% for oxygen. So now we have our mass percent values for each element. What we're going to do now is convert those percentages into decimal form and multiply those values by the total mass of the magnesium nitrate sample, which was given to us in the question as 58.4 grams. The mass percentage of magnesium is 16.38%, which when converted to decimal form is 0.1638. And so the total mass of magnesium in the 58.4 gram sample will be 0.1638 times 58.4 grams, which equals 9.57 grams. Similarly, for the mass of nitrogen, we convert the 18.89% into its decimal form of 0.1889, and so the mass of nitrogen will be 0.1889 times 58.4 grams, which equals 11.0 grams. And finally, for the mass of oxygen, we convert 64.72% into its decimal form of 0.6472, giving the mass of oxygen to be 0.6472 times 58.4 grams, which equals 37.8 grams. And finally, just checking our result, when we sum up these 3 mass values, we get our total value of 58.4 grams of the magnesium nitrate sample.